Hello, good evening. Today I'm going to be doing test 2. So I'm going to start with lesson 7, question 7. And it's asking determine if function f of x equals absolute value of x plus 7 is differentiable. So in order to draw this, we can go ahead and start at -7. So it should look something like this. Okay? So that we see here on the negative side, the slope is -1. And on the right side, the slope is +1. So here we're able to interpret that on the -7 minus limit, which is this side, the slope is -1. And the -7 plus, going from the right, the slope is +1. But if we were to draw this out, we would get this. Let's say -7 is here. The positive slope would look something like this, and the negative slope would look something like this. So the only thing that's differentiable is the -7, because it can't apply to both. So what is differentiable is -7 as the x. Because if we were to plug in -7 here, we would get 0. Okay, next question. Given graph of f, sketch f prime. So first step is finding the slope. And how do we find the slope? We find delta y over delta x, which is also equivalent to the rise over run. So if we were to take this here to find the slope, we would find that we go over 4 points and we rise over 4 points. So we would do 4 over 4, which is also equivalent to 1. So what this means is, in the f prime graph, any point on the rectilinear line, the slope is going to equal 1. So it should look something like this. Obviously imagine it's straight. Sorry, I can't really draw a straight line. But yeah. So that's what f prime would look like. Okay, now similar to question 7 we did, we have to sketch the graph of f prime. So let's do some limits. So if we were to approach 4 from the negative side, the slope would be -1. As we see, the slope is going down like that. But if we were to approach 4 from the positive side, the slope would be linear, or not linear, positive, because as you can see, it's going up. So if we were to graph this, let's say 4 is here, the graph would look something like this. Because the graph is differentiable at point 4. So these lines will never intersect, or they will never touch, because of point 4 here. So that is the solution. Okay, now one of my favorite lessons about derivatives. So first, find the equation of the tangent line f of x equals 3x cubed minus 10 at point 2, 14. So first we're going to find the derivative of this. To find the derivative of this, we must use the power rule in this case. 3x cubed, what you do here is you multiply n by this number in front of the x, and then you subtract 1 from n. So 3 times 3 is 9, and then 3 minus 1 is 2. And since there's no x on the 10, this is all we're left with. But they gave us the point 2 comma 14. So let's go ahead and plug that in. As you can see, 2 here, 2 here. 2 cubed, or 2 squared is 4. 4 times 9 is 9, 18, 27, 36. So this is going to be the slope of our equation. And our equation is always going to be this. Y equals y1 plus m x minus x1. So let's go ahead and plug it in. Y equals y1 is 14 plus m, which is 36, parentheses x minus our x1, which is 2. Now we do some simple distributive property here. 36 times x is 36x. 36 times negative 2 is negative 72. Don't forget the plus 14. Add combine like terms, and we're left with y equals 36x minus 58. So that is the equation of the tangent line of f of x equals 3x cubed minus 10 at point 214. Okay, question 9. So in order to solve this, we must first find the derivative. So, like I said in the previous question, we use the power rule. So the derivative of this, since 3 doesn't have an x, that's already automatically knocked out. So the power rule says multiply the exponent by the variable, so we're going to be left with 4x, and then subtract 1, which is 3. And then do the same to the other one. We're going to be left with minus 4x. 2 minus 1 is 1, so there's an invisible 1 there. So pretty much the whole point of the question is we're trying to find what x's would make the line look like this. A straight line. So we must factor this further. How can we factor this? Well, we can take out the 4's. We'll have with x cubed minus x equals 0. We can factor even further by making the equation look something like this. And now, here's what we're going to do. We need to find all the possible x's that will make this equal to 0. Well, here's what we know. We know obviously if we plug in 0, that's already going to be a point. But 0 squared minus 1 is negative 1 times 0 is 0. 1 squared minus 1 is 0. 1 times 0 is 0, so we can do 1 as well. Negative 1 was going to be the same as positive 1 because it gets squared. So that's also going to equal 0. But we're not done because it's asking for the points, not just the x's. So what we're going to have to do is we're going to have to plug in all these x's into our original equation. So let me write down the original equation here so that we don't forget. And then let's start. So let's say 0. This is already canceled out. This is already canceled out. We're left with 3. So our first point is going to be 0, 3. Now let's try with 1. Let's see. 1 minus 2, 1 squared plus 3. All right, let's solve this. This is going to equal 1. This is still going to equal negative 2. So 1 minus 2 is negative 1 plus 3 equals 2. So our next point is going to be 1, 2. Now let's find our last one for negative 1. Negative 1 minus 2 we're left with, this is going to be positive. This is still going to be negative. So they're going to equal the same. So now this means that the lines would look something like this. 0, 3, let's say this is 3. That's one line. 1, 2. This is another line. And negative 1, 2. It's going to be this line. So as you can see, it should look something like this. So that is the solution to question 9. Okay, now we need to find the derivative of the trigonomic function f of x equals x squared plus tan x. Okay, so let's go ahead and do this. So f prime of x equals, well, we can already do the power rule with the x squared. So we're going to be left with 2x tan x, and then the derivative of tangent is secant squared x, because tan x equals sine x over cosine x. So let's find the derivative of sine x. And the derivative of cosine x is negative tangent x. Oh, sorry. Okay, so now let's do some more complicated math here. So the derivative tan x is equal to cosine x squared plus sine x squared over cosine x squared. Simplify this, we're left with 1 over cosine, which is also equal, it's also equal to secant squared x. So that is the solution. Okay, find the second derivative of f of x equals x over x minus 1. So let's go ahead and do it. Okay, so in order to find the derivative, we must use the quotient rule. So f prime of x is equal to 1 multiplied by the denominator, and the derivative of the denominator, we know that 1 doesn't have 1 and x has 1, so that. And then obviously we square the denominator, and then we solve. So if we were to simplify this, we will be left with negative 1 over x minus 1 squared, which is also equivalent to negative x minus 1 to the negative 2. But we need to find the second derivative. So we need to use the power rule first, because there's a negative there. And then x minus 1, negative 2 minus 1 is negative 3. And then we're left with 2x minus 1 to the negative third, which is also equivalent to 2 over x minus 1 cubed. Okay, find the equation of the tangent line to the graph f of x equals 9 minus x squared to the 2/3 power at point 1 over 4. So we found the u, which is this, the inside of this. And we found the derivative of u, which is minus 2x because of the power rule. So now f of u equals u over 2/3, or to the 2/3 power, and delta f, or not delta f, derivative of f is 2/3 u to the negative 1/3 power, which also equals 2 over 3 to the cubic root of 4. So let's solve this using the chain rule. So if we were to plug in our numbers here, we get 2 over 3 to the cubic root of 4 times minus 2x, which would also equal negative 4x over 3 to the cubic root of u is 9 minus x squared. Now if we plug in our x, which is 1, we would get negative 4 over 3 to the cubic root of 9 minus 1, which is 8, which would also equal minus 4 over 6, which would equal minus 2 over 3. So now we plug it into our trusty equation that we always use. Since we just found the slope, y(o) is 4 plus negative 2/3 multiplied by x minus 1, y equals 4 minus 2/3 x plus 2/3, which is also equivalent to 4 times 3 is 12 plus 2, 14 over 3 minus 2/3 x. So that is the solution. Okay, find the derivative of f of x equals 5 over x cubed minus 2 at point -2, -1/2. All right, so let's go ahead and find the derivative. This equation is also equal to this, multiplied by 3x. So that's the derivative of this here, using the quotient rule and the power rule. So now let's go ahead and simplify it. And then we can go ahead and plug in our x. And if we do all the math for this, it's going to equal 60. And since it's only asking for the derivative, we can go ahead and end it there or there. Okay, now question 51. The question is asking, at what rate were the gross annual earnings of the company growing with respect to time in 2012? And we know that the formation only started in 2008. So obviously we know that from 2012 to 2008, that would be 4 years. So what we have to do is find the derivative. So to find the derivative of this, we have to go ahead and use the power rule on the first one. 0.1 times 2 is 0.2. And then we're left with 10t. Take out t, we're left with 10, and then 20 doesn't have a variable, so that's left out. So now all we do is simply sub in our t, which is 4, so 0.2 times 4 plus 10 equals 10.8. This means that the rate of growth is 10.8, and it's in thousands of dollars, so 1,000 per year. Now let's go ahead and find B. Now we need to find the percent rate of growth. So we need to put A prime of t over A of t times 100. So let's do this. A4 equals 0.14 squared plus 10 times 4 plus 20, which equals 61.6 thousand. So if we put the original price per year over 61.6 and then multiply it by 100, we should get the percentage, which is approximately 17.53%. So that is the answer for part B.